attributes ID name, add those in a generic list and get all the objects back from the list. So this is very simple. You don't have to write a generic collection. You have to only use the generic list available. Okay. Partial type.
Tanvi, this is Ramya here. Now, how do we send these assignments, Tanvi? Do we need to write the code and mail it to you, or?
No, there is no need to email actually, Ramya. If you are good, if you think that you are getting it, and if you are able to do, I don't need the assignments actually.
Okay.
But if you have any problem, then you can email me.
Okay. Okay, Tanvi.
Okay. Partial types. Anyone has any idea what partial type is? Partial type is you can break up type. It can be class, it can be structure, it can be interfaces into multiple files. So let's say in your application you have file 1.cs. You are writing class A and M1. Then again in the file 2.cs, same application, again in the same application, again class A and method M2. So partial types, it is that this class is not completed here and you have reopened it in another file. So from the point of compiler, it is like class A and you have method M1 and M2. Okay. So that's all is the partial type. There is no difference in the behavior, everything same, only thing is syntax, you are breaking up your type into multiple files. Okay. So if you write M1 here, again M1 there, you will get an error, syntactical error, that you cannot redefine method M1 because it is already defined, because it is treating class A as the same class. Okay. Defining a class across multiple files, class or basically type, which can be structure interfaces also. So compiler, what it will do, it will merge the code from the various files ultimately into the single compiled class. Okay. So it will be a compile time error to declare two elements of the same class first in different, either it is in the different file. Okay. So you have a customer class where you have declared only fields. Then again in another file you have same class customer. Okay. Another important thing, you have to use this partial keyword. Then only it will become a partial class. And again in another file you have again class customer with the partial keyword and you have methods. So ultimately compiler will have a customer class, all these fields and all these methods, a single class. Okay, any questions here? Okay, so we'll move on. It was actually very simple partial class, partial types. Delegate, we'll start with delegate. Anyone, any idea about delegates?
It is a pointer to a method.
Pointed to a method, very good. Anyone else or anything else?
We have to use the keyword delegate.
Just to trigger the event in the runtime.
Event in the runtime, okay. That's a good point. Okay. So delegate is like in C++ also we had function pointers, kind of function pointers, but not completely. So it is a type. So delegate is also a type. Like a class is a type, a structure is a type, delegate is also a type, but it can refer a method or it can point to a method. So when you create object of delegate, can you create the object of delegate? Yes, of course, because it's a type. Ultimately, underneath we use the delegate keyword, but underneath it's a class which is being inherited from system.multicast namespace, multicast class. So delegate itself is a class. So we can create the object of delegate. When we create the object of delegate, that object can hold references to methods, method or methods. So when we invoke that delegate object or delegate instance, those methods will be called. This is how it is. Let's say this is a delegate object D, there are method 1, method 2, method 3. So this delegate is holding reference to these methods, pointing to these methods basically, holding reference to these methods. So when I invoke this delegate object, these methods will be called in sequence. Which sequence? The order in which they were being added as a reference to the delegate. So let's say I have first added the reference of M1, so it will be called first. Then I added the reference of M2 to D, so M2 will be called. Okay. So a normal method, generally a method, how do we call a method? Like this, with the method name. But here we are not calling method, these three methods with the method's name, but we are calling them through delegates. Is this point clear? So delegate method can be used like any other method with parameters and a return value. So if you will see how to declare a delegate in C#, this is the kind of syntax you will observe. Public, delegate, int, name, and input parameters. So everything you will see except this thing, it is like how you define a function. Okay, but when you use the delegate keyword, it is you are defining or declaring a delegate basically. So what does delegate? This is the name of the delegate, perform calculation. So this delegate can refer to methods, but only those methods which are following the signature of this delegate. So methods which have to input integer and return also as integer, this delegate can only refer to that method. Okay, so print calculation delegate, let's say I created an object of this delegate obj. I have a method integer add int comma int. So this method, this object can hold reference of. Okay, if I have another method, let's say void print, this object cannot hold the reference of this method because this is not following the signature of the delegate this object belongs to. Okay, is this point clear? Are you getting it, guys? Shubha, Shobna, Ravikant, Rupa.
Yeah, I'm getting, but can you tell with some that example?
Yeah, we'll do the example. Definitely, we'll do the example. Okay, so delegate is allowing the method to be passed as a parameter. So far, we are writing methods, we are passing parameters. Okay, like integer I, float I, like this. But with the usage of delegate, you will see that in the parenthesis, we will pass methods. We will see how. Delegates can be chained together. For example, multiple methods can be called on a single delegate invocation, which is actually event. So delegate is actually introduced in C# to support event handling. Okay, we'll discuss what event handling is. First, we will be sure about what delegate is, then we'll discuss what event handling is. So as I gave you the example, D is holding reference to M1, M2, and 3. So when I invoke D, it is calling all three methods. Okay, so this is basically on a single event, multiple methods or handlers are being called. Okay, this thing is we call the multicast delegate also. Now where we can specify delegate as it is a class, we can directly specify them in a namespace, or we can specify them within another class, because next class is also possible. And as I said, delegate itself is a class. In each case, ultimately, we are adding a class which is inheriting from system.multicast delegate. This is what delegate is, a class which inherits from this class. Each delegate is limited to referencing methods of a particular kind. What particular kind? The signature of the delegate. The type is indicated by the delegate declaration. So signature is when we declare the delegate, that time we declare the signature also, that this will be the input and this will be the output or return. So the methods which is following the signature can be referred by the delegate. Not all the methods. Okay. Now here I am declaring a delegate print. Okay, this is the delegate. Okay, now I have a real method here. You can see a method. The name is real method. The method name is real method. Now, can this delegate, can it point to this method? Can this print delegate point to the real method? Yes, okay, it can point because the same signature. In the delegate, nothing is there. Sorry, in the delegate, it is void and string. It is void and string. Okay, so it can point to this real method. Now, how it refer? I mean, point means it can refer to this real method. Now, how to write the code so this delegate object will point to this real method? So, the same way how we create the object of a class, the same way we can create object of delegate. So, print delegate name, object name. Okay, the same way new delegate name. Okay, because ultimately it's a class. And then you can see here what we are passing is the name of the method. Okay, so in the delegate we are passing the name of the method. So now this delegate variable, which is the object, is pointing to real method. Okay, now there are different syntax you can use. The same thing is like this dot real method. So real method, this means for the current object which is being executed in the memory. So this is the same thing. Or if this method to which this object is pointing, let's say if it is in another class, okay, so you can use the name of the class or the object. If it is the static method, you can use the name of the class. If it is the non-static method, you can use object of that class. Okay. So I'll do one example and we'll see if it becomes more clear. Okay, another thing, multicast delegate. Multicast delegate is one delegate is pointing to multiple methods. So let's say print s. This is a delegate object s. This is null. So initially it is there, but it is not pointing to any method. Then we added real method. So it is pointing to real method. Then we again added another real method. These are methods. So it is pointing to this method also. So when we invoke this, first real method will be executed, then other real method will be executed when we invoke the delegate. Okay, so let's do an example for the delegate. So we have declared a delegate. Now you can see we can declare a delegate outside the class or directly because it's another class as we are declaring. So delegate int delegate to method. This is the name of the delegate. Okay. So this is the signature of the delegate, int return and two input parameters of int type. Then I have a class math. In the math you can see I have static functions, add, multiply, divide. Okay. And all three functions are following the signature of this delegate. So can this delegate object point to all of these methods, add, multiply, divide? Can it point to them?
Yes.
Yes, because they are having the same signature. Now how we are pointing it to them? First I have created one object. This is a single cast delegate, not multicast. One delegate object is pointing to only one method. So this is one delegate object, a delegate, which is pointing to add. M delegate, which is pointing to multiply. D delegate, which is pointing to divide. Now this math we are using because these methods are in different class, which is class math, and those are the static methods, so we are using the class name. Okay, now this is reference has been said. A delegate point to add, M delegate point to multiply, and D delegate point to divide. Now reference has been said. Now when we invoke a delegate, how we can invoke? Object parameters. Okay, so two input parameters of delegate. So when we invoke this, it will actually call this method. When I invoke M delegate, it will call multiply method. When I invoke D delegate, it will call divide method. Okay, so on the invocation of delegates, we are calling the methods. They are pointing or referring to a method. Okay, is this clear example? Is this example clear, guys?
It's clear.
Okay, everyone
but,
clear?
Clear, but what is the actual use of here by using the delegate?
What is the use is, first of all, this is the thing where we are creating different objects. Okay, so first is you can only create one object and add all the references. Okay, so you don't have to explicitly call first add method, then multiply method, then divide method, right? You can just call a delegate 5. So it will, by these parameters, it will first operate add, then multiply, then divide. Okay, so multiple methods you are able to call with one invocation. This is one thing. Another thing is this is useful in event handling. This is the concept which will be used in event handling. What event handling is, what an event is, like when I am pressing the key. Okay, so that is an event. When I am moving the mouse, that is the event. When I am clicking the mouse, that is an event. So event handling is if some event occurs, then handle it. Handle it in the program. Handling means execute some code when some event occurs. So let's say on mouse click, execute some code. Okay, so generally method, a normal method, how do you call a normal method? It's the method name, because you know when to call them in a program. But in case of event handling, you don't know when to call a method. There is a method which you want to execute, but you cannot call it with the name, but you want to call it when some event occurs, right? So what you can do is you can just use a delegate which will point to the refer, and when some event occurs, that time you will invoke the delegate. Okay, so it will automatically call the handler. Are you getting it?
Yes.
Okay, so this event handling will go in detail after this delegate. We'll do this event handling in detail. So ultimately, this was introduced for this concept of event handling. This is just in short how you can use the delegate. First define it. Define the delegate with the delegate keyword. The method or a instance method, static method, whatever you want. Write a method to which this delegate object will point to. Create a delegate object. Pass the method as the reference and invoke the delegate object. Okay, so these are the 4 steps for the usage of delegate. Now again there is one more assignment for delegate. The delegate which we used here in example is single cast, right? Every delegate is pointing to single method. Now convert the same example to multicast basically. So you don't have to create these two, but your a delegate is this only one object should point to all 3 methods. Okay, and there will be only one invocation of delegate, and it should call all 3 methods. Okay, so you will have to add the reference of multiply and divide also here. Anyone, any questions here? Shobana, You are getting it?
Can you come again for this multicast?
Multicast delegate is, yeah. See, here is a delegate. In the example what I demonstrated, we had a delegate pointing to add method. We had m delegate pointing to multiply method, right? So three different objects are there, three delegate objects. D pointing to divide. Okay. So you have to convert it into the multicast, which means only one object. You can name it whatever you want and points to all the methods. Multiply and divide. Okay. When you call this, all the methods should be executed in this sequence. This is what you have to do.
Okay, now you are trying to say that if call this method, these three will be called. I mean, if a new delegate that mat.odd will call these three. You are trying to say like that?
Yeah. Yeah. So delegate object is pointing to all three methods. So when you call the delegate object or invoke the delegate object, these three methods should be called. Here also we are calling these three methods, but with different objects.
Yeah.
Okay. Now you have to call with the same object.
Okay, this maths.add will call these three methods.
Not the maths.add, this delegate object.
Yeah, this delegate object will call these three.
All three methods, yes. Only one object will call all the three methods.
We have specified as that add, no? Then
No, so you have to, no, you have to write. You have to write the code so that it will refer all three methods. This is what you have to do.
That's what I asked.
This code,
okay.
Yeah, this code is not completed.
That's what I asked. I got it. Okay.
Yeah. You have to write it. This is what the assignment is.
Okay, fine.
Okay.
And also, Tanvi, in that case, add, multiply, and divide all will have the same parameters. That is, like in case if we are using 5, right?
Yeah. On the 5 you will operate add, multiply, divide on the same parameters.
Okay.
Okay. Anyone else? Okay, so shall I move on? Okay, next is anonymous method. What anonymous method is, anyone?
Anonymous methods, like basically when we have a very small method, say a method contains a single line of execution, I mean, or a code, it is very small basically, then we give it in the, when we create the delegate itself, we give it inside. So we just remove the method and we give the contents inside the delegate itself. So that is anonymous method.
Okay. And what is the use of writing anonymous method?
Yeah, use is basically, the overhead of creating, overhead of instantiating the delegate is removed.
Okay.
And it can be used basically when the method is small.
Okay. Yeah, that's right. So we'll see a little bit in more detail. So anonymous method, you can see as the name says anonymous means there is no name for the method. So method without name, unnamed method, and lined method. Lined, which we'll see how it is a lined method. It is used with delegates. So generally, how do we write a method? M1 and then write a method. So in this method, you will not have names. Okay. And how do we call the method? Like this. Okay. So if you don't have a name, how will you call it? So you will call with the delegate. Okay. The object, delegate object will refer to this method, and when you invoke delegate, this method will be called. This method will not be called through the method name because it doesn't have the name. Again, generally, practically, the method which have very short code, as Ramya says, we write that method in the anonymous method, in the form of anonymous method. And one more important thing is, when M1 is here, defined here, you can call it as many times as you want in the program, okay, with the name, okay, with name. But in this method, the method which you don't want to reuse over and over again, which you don't want to call again and again, you will write anonymous method, okay. And in this method, generally in a normal method, the definition is here and we are calling it from somewhere else, okay. Then we have some more code in between. But here we are keeping the calling and the implementation as close as possible. Means very close. The calling and the implementation is in the same line. Okay. Now we'll see how to write anonymous method. This is how we write anonymous method. So you can see there is no name. The method does not have name. Okay. So we are using a delegate keyword. Then input and then code in the method. So this is an anonymous method. Okay. Now what is the return type? How will you know return type? What will be the return type of this method? We did not specify the return type. In a normal method, we specify the return type, but here we don't, because it will be automatically inferred from the delegate declaration. So ultimately, this anonymous method will be pointed by some delegate, then only we can call it. So with the delegate specification, the return type will be inferred, or compiler will understand from the definition of delegate. The declaration of the delegate. Now I'm writing this code. Now you can see I have a delegate with void return type. Name of the delegate is delegate test and string as input argument. Okay. Now see this thing, this line of code. What is this? From here to here. This is anonymous method. Okay. Now this anonymous method is pointed by this delegate object. Okay. So what will be the output return type of this delegate? So the output of the method, compiler will automatically understand that it is going to be void, because this delegate is pointing to this method, and if it can point to the method, that means it has the same signature of the delegate. Otherwise this is not possible to point from this delegate. Okay. So now you can see the method definition is close to the method calling. Okay. Again, this is another method. The same object is pointing another anonymous method. Okay. The method is different, but still the signature is same as delegate. Now when these methods will be called? When I invoke the delegate object. So here, when I invoke the delegate object, this will be passed here in place of name and the code will be executed. Then the same parameter will be passed here in place of address and same code will be executed. So these are anonymous methods. Okay. Is it clear, guys? Okay. Anyone, any doubt? How much time we have left? Next is 15 minutes. Yeah. Next is event and event handler. I don't know how much time it will take. Okay. Please do some basics of event handling, and then the exam we can see tomorrow. Okay. Anyone, what is an event and what is event handler? What is event, Shobha? Shubha, sorry.
Event means mouse click or button click or mouse over or those are the event handlers. But in Java it is an interface, so we implement event handler and we can call the methods in that interface. Like on click what happened or
Okay.
get the data from the text box or if the button click what will happen.
Okay. Okay. Anyone else? What event is? What event handler is?
Event is a method, but event handler will decide which method need to be called in the runtime.
Okay. Okay. Ramya?
Event is basically, you know, it comes with delegates, and what it has to, I'd say like when something is triggered, that is called as an event, and what has to be done during that event is managed by the handler.
Right. So basically we have two things, event, trigger. So what some action is getting triggered, click, key press, key down, key up, okay, left click, right click. So these are events or button click. So events is some action is being invoked. Okay. So one is in C#, one will be event raiser class. Okay. Another thing is when I click on a button, let's say Shubha says on a button, click, gets a text from the text box. So getting text from text box is code to be executed on this event. Okay. So this thing, button click event, this event will be in event raiser class. Event raiser class will raise an event. Okay. And what will happen on that event will be within the event handler class. Okay. So there will be some method M1 or any method in which you will fetch the data from the text box, or you will write the code which needs to be executed when someone clicked on the button. Okay. So button click event will be raised from event raiser class and it will be handled here in the event handler class. Event handler class. Okay. So again, concept of delegate comes, right? So we cannot call this event handler explicitly with the name because we don't know when this event will be invoked. Okay, you cannot call it in the program, but it has to be called on some action. So event raiser class will maintain a delegate, right? And that delegate will hold reference to this method, which is event handler. Okay, so when action happens or event happens, this delegate will be invoked on event. This delegate will be invoked and this delegate will ultimately call this method. Okay, or one event can be handled by multiple methods also, because this is also possible with the concept of delegate. Okay, or the other name is event raiser class. You call it the publisher class also. Publisher class publishes the event. Okay, and event handler class you call the subscriber. It subscribes for that event, that when this event will be raised, then this will be handled in my class in this method. So that will be the event handler. So it is following the publisher subscriber model. So event handler is a special method. Ultimately it's a method, but it's special method which will be invoked when some event is raised. So that method invocation is termed as an event, and running of that method is event handling. Okay. So for example is when we click on a button, when we change selection from the drop down list. So all these are event, button click event, selection changed event, and on these users event, the code, some code is being executed from the handler class. a class must be able to subscribe to a particular event and then receive a notification whenever the event occurs. Okay. So subscriber class will subscribe to the event and it will automatically get the notification through the delegate whenever the event occurs in the handler class or in the raiser class. Okay. So now delegates are must here for this implementation of event handling. So let's say class 2 subscribes to an event issued by class 1. So class 1 will be the event raiser class. So this class will maintain the delegate. Okay. Now class 2 is subscribing to that event, means it will handle that event or it will respond to that event with its method. So class 2 will be the event handler class and there will be some method which will be handling the event. So basically D is going to hold the reference of this method M. Okay. So whenever class 1 wants to issue an event, what it will do? It will invoke this delegate D. Okay. Then it will invoke all the methods which it is holding references of. Okay. And in this case, it is holding reference of method M. So it will call the method M. So ultimately, whenever a class 1 is issuing an event, the D will be invoked, delegate will be invoked, and then all the methods will be executed. Okay. So in the publisher class, what we will have? We will have three things in the publisher class. One will be the definition of the event and the delegate. The event delegate association. What is event delegate association is? Pointing, holding a reference of method by delegate. So that is event delegate association. This is also will be in the publisher class. Okay. Whenever publisher class will invoke the event, it will notify to the other subscriber objects who has already subscribed. Okay. How to subscribe? Subscriber will have to provide that this event will going to handle the, this event handler will going to handle the event. Okay. So the subscriber class object will accept the event and will be handled in the event handler. This is what is happening. Now, see the example tomorrow how to write event and event handler. How to write basically event raiser and event handler class. We'll see it tomorrow. Is it okay, guys? So tomorrow we'll try to finish C# and then we'll start with ASP.NET. Okay. Very few topics are left in C# 3.0 and sorry 2.0 and C# 3.0, 4.0 will do with the ASP.NET itself with the link technology. Okay. Anyone, any questions? Shall we close it off for today?
Yes.
Okay.
Okay. So see you guys tomorrow, same time.
Okay, Tanvi. And thank you.
Okay. Thank you, everyone.
Thank you, Sunny.
Yeah, bye bye.
The organ